Welcome to OBS Group.
Hey guys, as Matt and Joanna said, welcome to OBS Group. Today we're doing our fourth installment of our workflow series. Over the past 10 or so years, we've done hundreds of different implementations of various workflows. Those workflows can generally be grouped into three basic categories. You've got data-driven workflows, like the well review workflow we did in our first session. Task-driven workflows, like the opportunity tracking tool from session number 2. And then you've got model-driven workflows, which we'll be covering today. So in fact, our first workflow we ever deployed commercially was a gas lift optimization workflow using a well model. Since then, we've implemented a lot of different types of model-driven workflows, and of course, the technology has improved over time, the automation has improved over time, and we've made a lot of big improvements and helped a lot of different clients doing model-driven workflows. So that's what we're going to be discussing today. Let's have a look. So when we talk about modeling, we are effectively trying to simulate some aspect of our operation, but there's a lot of different types of models. Geologic models, simulation, narrow wellbore, fracture models, nodal analysis models, surface network, equipment on the surface, and then we've got to consider parts of the models. Are they going to be compositional in nature? Are they going to be thermal? There's a lot to consider when putting models into the system. But when we string these together, we can effectively build a digital twin of our oil field. All of these models require input from real-time data or multiple different data sources and potentially in different silos. And they all need to be calibrated and updated regularly. When they are, however, they can effectively help us plan and design the operations in our field, help us make operational decisions or what-if decisions in our operations, perform effective surveillance, optimize our production, and then also provide input to the rest of our business activities. Put together, they can be very effective. The trick is keeping them updated and evergreen. So let's take a simple example using OBS. Here we're going to use a model and a series of workflows. First, we need to confirm that our well model is properly calibrated. So as part of an automated workflow, OBS's surveillance server is continuously monitoring a well test database. When a new test has been conducted, the system automatically runs a well model and compares it to the well test. Here we see a model and well test that are within 5% of each other, giving us a green light. We can still use this opportunity, however, to improve the accuracy of the model. So let's go to the well model validation workflow. Here we see a lot of information from the database as well as the well model. It appears that we have two model runs in this case. A user, in this case called engineer, has created a sensitivity but not committed it to the official model. We can see how this compares to our current model if we look at the visualizations for gas lift performance and our IPR curves. Also, as part of the workflow, we can see both the model results as well as the model inputs. Now let's see how we can improve our model prediction using our current well test, reducing it from 4.9% error to somewhere closer to 0. Our current model is using a reservoir pressure of 1351 psi. In our evaluation input panel, we also see that our OVS is providing some assistance in obtaining a match. It seems that if the reservoir pressure is changed to 1327, we could achieve an exact match. We could also change the productivity index or GOR to get a match. Let's try and run the model first with 1310 psi. Now OVS will update the model, run the model, and automatically bring back the results. We see that using the new reservoir pressure, we reduce the error from 4.9% to 2.7%. We could continue to tweak, update the official model, or simply move on. If we choose to save it to the model, it will update the model in the OBS Model Manager, so the most accurate model can be used in other workflows. Now that we have an accurate model in place, other workflows that use the model can be trusted. Since it's a gas lifted well, this model can be used to provide diagnostics about the system. It can be used to provide production improvement opportunities by changing the gas injection. Finally, in this case, it can be used to perform virtual metering, where the model is fed real-time sensor data and run to produce a virtual flow rate at any desired frequency. The results of the virtual metering can be used in other systems like production allocation. Of course, OVS is not only just used for gas lift. Here's a model workflow using an ESP for artificial lift. So that was an example of using OVS with a single well model, but models can feed other models. Let's take, for example, one of our recent clients where they had a material balance model that fed well model or well models. Those were performed across hundreds, if not thousands, of wells. The results of the well models were used to feed the surface network. The surface network, in turn, was used to feed the compressor models. The compressor models impacted the results of the surface network as well. This was done across multiple surface networks and ultimately fed into the processing facility. So you can see with the sheer number of models being used, the upkeep of them proved to be quite daunting. So OVS was brought in to automate the population of all of these models and then used to run the models more frequently. We're able to reduce the upkeep from 1 man week per month down to just minutes, and we were able to run the models more frequently. Now, as a result, they have a continuous process of monitoring their entire network. As oil and gas companies continue to grow their digitalization practices, the use of models and simulators will also continue to grow. We feel that OVS can be a key enabler in keeping those models up to date and incorporating them into your day-to-day workflows. We at OVS Group would like to thank you for joining us here today. Please reach out to us with any comments or questions that you may have. Thanks again.